Hello, Brenna and Saw here.
Today we're talking about expanding and reducing fractions. So Brenna and I are going to order a pizza. Here's our pizza. Half of the pizza is mine, and half the pizza is Brenna's. I'm going to color mine in pink just so we know which one is mine. Now I'm going to cut the pizza into smaller slices. So we're going to cut this pizza into 6 slices. So now, instead of having one slice out of the 2 slices, there are 6 slices in the entire pizza. 3 of them are mine. So 3/6 is an equivalent fraction to 1/2. We have the same amount of pizza, it's just cut into smaller slices. We did this by expanding the fraction 1/2, so that is equal to 3/6. Now Brenna's going to tell us how we did this mathematically.
Thank you, Saw. They showed us that the fraction 1/2 is equivalent to the fraction 3/6. Well, mathematically, what happened here? We created 3 times as many slices total and for each person. So the original 2 slices times 3 gives us our new denominator, or 6 total slices, and our original numerator of 1 times 3 gives us our new numerator of 3. So note that the numerator and denominator both got multiplied by 3, but there's really nothing special about the number 3. We know we can cut our pizza into really any number of slices we want. We could have chosen 8 slices total, in which case each of us would have gotten 4 out of those 8 slices. In that case, we created 4 times as many slices total and for each person. Our original denominator of 2 times 4 gives us our new denominator of 8. Similarly, our original numerator of 1 times 4 gives us a new numerator of 4. So we see that 1/2 is equivalent to 3/6, which is also equivalent to 4/8, just different ways of writing 1/2. So in general, let's see if we can come up with a rule for expanding fractions. Say we have any numerator a over any denominator b. Well, we want to create a fraction with the same numerical value, and we can do that by choosing some number c to multiply by both the numerator and denominator. So this will be our general rule for expanding fractions. And we will use this rule for the next few examples.
So Brenna just showed us how we can expand fractions by multiplying the numerator and the denominator by the same number. We can do this with any fraction. So we already did it with 1/2. What if we did it with 2/3 instead? I would like to give 2/3 a denominator of 12. So I'm going to take 2/3. So I'm going to take my numerator and my denominator, and I am going to multiply these both by 4. Two times 4 is 8, and 3 times 4 is 12. So 2/3 and 8/12 are equivalent fractions, which we expanded by multiplying the numerators and the denominators by 4. We can do this with any number. So there's nothing special about the number 4. So if I wanted to multiply them by 5, I could do the same thing and get a different denominator. So I'll take my fraction 2/3, and I will multiply my numerator and my denominator by 5. 2 times 5 is 10. And 3 times 5 is 15. So 2/3 is also equal to 10/15, which we found by expanding the fraction by multiplying the numerator and the denominator by 5. There's nothing special about the fraction 2/3. We could do this with any fraction we wanted.
Really? Any fraction?
Yeah, any fraction.
Okay. Wow, well, I want to try one then.
Yeah, let's try an improper fraction. So we have 7/4.
Okay.
Do you think we could make the denominator in 7/4 the same as the denominator in 8/12?
Yeah, I think so, because I know 4 times a number can equal 12. Let's see. So I am going to take the numerator and denominator and multiply them by 3. Is that the magic number?
Yes, it is.
All right. So our new numerator will be 7 times 3, which is equal to 21. And our new denominator will be 4 times that same number 3, which I believe is 12. Did that just work? Is that an equivalent fraction to 7/4?
Yes, it's an equivalent fraction, and you expanded them by multiplying the numerator and the denominator by 3.
Sweet. And I think in a future video, we'll see how fractions with the same denominator can be quite helpful. But I like the flexibility we have here, and that's the story for expanding fractions, and I think we'll switch to reducing fractions.
Yep.
Do you like pineapple on your pizza?
Yeah, who doesn't?
Gross. So if we're going to be sharing a pizza, let's see, if they cut it into 8 slices, I'm going to want 4 without pineapple.
And I want 4 with pineapple.
But we wouldn't tell the person at the pizza place that we want 4/8 pineapple, would we?
No, I think we would tell them we want half the pizza to have pineapple because for a normal person, and half the pizza to not have pineapple for weirdos.
All right. So we really just reduced 4/8 into 1/2. Let's see what the math is behind this. So we observed that 4 out of 8 slices of pizza can be more simply referred to as just 1/2 of the pizza. 4/8 is equivalent to 1/2, but we've gone the reverse direction this time. We're no longer expanding, we're reducing the fraction. So we're going to need the opposite of multiplication, which is division. What do we need to divide 8 by to get to 2? Well, 8 divided by 4 would give us our expected denominator of 2. And surprise, if we divide by 4 in the original numerator as well, we get our new numerator of 1. Okay, so generally speaking, what is the rule we are applying here? If we have some numerator a in our fraction and some denominator b, we can create an equivalent fraction by dividing the numerator a by some number c and dividing the denominator by that same number c. And it's going to be important to know what factors are, because we're going to want this number c that we pick to be a factor of both the numerator a and denominator b. That is, it divides evenly into a and evenly into b. Okay, so we'll use this rule to reduce some fractions.
Now that Brenna has shown us that we can reduce fractions by dividing the numerator and the denominator by common factors, let's try some out on our own. So for example, let's look at 6/15. If I want to reduce 6/15, I need to find a common factor between 6 and 15. I know that 6 and 15 are both divisible by 3. So if I divide my numerator, 6, by 3, and then if I divide my denominator, 15, by 3, I will get a reduced version of the fraction. So 6 divided by 3 is 2. 15 divided by 3 is 5. So the reduced form of 6/15 is 2/5. We can do this with any fraction that we want.
But first, how do we know this is fully reduced? Couldn't we keep dividing 2 and 5 by other factors?
Well, do 2 and 5 have other common factors?
They're divisible by 1.
Let's try dividing them by 1.
Oh, I see. Dividing by 1 does not change the numbers, does it?
No, we keep it at 2/5.
Okay, it's a good way to check, though, that we're done reducing.
It is.
Okay, can I try one?
Yeah, let's try it out. So let's try an improper fraction. Let's try 35/10.
Okay, I think I can handle that. We need to look for a common factor of 35 and 10. I think they're both divisible by 5, right?
Yes, they are divisible by 5.
All right, we have found the winner. So our original numerator of 35, we'll go ahead and divide that by 5. Same action in the denominator. We'll take 10 and divide by 5 as well. So hopefully we get our reduced version. 35 divided by 5 is 7. And 10 divided by 5 is 2. So the reduced form of 35/10 is 7/2, which does look quite a bit more simple. And are we done reducing?
Well, let's try dividing them both by 1 and see if we can get any further.
Well, again, even though 1 goes into both, that's the only factor they have in common.
Yep.
So we're done.
Yes, so 7/2 is the reduced form of 35/10.
All right. Well, here we didn't have very many choices of factors, so I think next we should try some numbers that have more factors and see what we do
Yeah,
there.
let's try some spicy numbers.
All right.
We can also try reducing fractions with bigger and spicier numbers. Like, for example, 42/72. These are pretty big numbers, and I don't know what their largest common factor is off the top of my head. So I'm just gonna try some stuff out. I know that they're both divisible by 2 because they're both even numbers. So I'm gonna see what happens when I divide them both by 2. So in my numerator, I have 42 divided by 2. And then in my denominator, I have 72 divided by 2. So my numerator of 42 divided by 2 is 21. In my denominator, 72 divided by 2 is 36. So 21/36 is an equivalent fraction to 42/72, but it's not a fully reduced fraction yet. So I can do this process again. So I'm going to take my equivalent fraction 21/36, and I'm going to see if I can find more common factors. So I know that both of these numbers are divisible by 3. So I'm going to take my numerator 21 and divide it by 3. And then I'm going to take my denominator 36 and divide it by 3. So 21 divided by 3 in my numerator is 7. 36 divided by 3 in my denominator is 12. So now I have 7/12, which is an equivalent fraction to 21/36 and is also an equivalent fraction for 42/72. We know that this is the reduced form of 42/72 because there are no common factors of 7 and 12. Now, we could have done this in fewer steps by using the common factor of 6 instead of the first common factor of 2 and then another common factor of 3. But we'll get to the same answer even if we do it in multiple steps. Now that's it for reducing fractions. Thank you for joining us today. We hope this was helpful.
Keep calm and math on.